All right, so this one's asking us to find the third degree Taylor polynomial about x equals 100. So let's continue like we've been doing. We'll have a table here. We want to make sure that we go out to 3 here because that's the one they asked us to find here, third degree. So we want to make sure we go to the third one. And then we got our different functions and their derivatives that we're going to be finding. And since they want us to find this one centered at 100, we want to find what these are then at 100. Okay, so our original function here is just square root of x. So that at 100, if we put 100 in, square root of 100 is going to be 10. Let's also, as we're doing this derivative here, we can think of this as x to the half. So if we do the derivative, our first derivative is going to be 1/2 x to the negative 1/2. If we put that 100 in for, 100 in for that one, that's going to be the same as 1/2 square root of x. So square root of 100 will end up being 10. So we got 1/2 times 10, which should be the same as 1/20 would be our first derivative evaluated at 100. All right, let's find our second derivative now. So if we, again, decrement this by bringing down the power, it's going to be negative 1/4 x. One less than that's going to be negative 3/2. So we want to find out what is 100 at that value. Let's use our calculator to help us with this one. So we got negative 1/4 times here 100 to the negative 3/2 power here, and we get that, which as a fraction is going to be negative 1/4000. All right, we got to do one more derivative here. So again, bring down our exponent. 2 negatives is going to make a positive, and this is going to end up being 3/8 x. One less than this is negative 5/2 here. Again, we want to figure out what that is to the, if we put 100 in there, this would be the same then as 3/8, or you could, again, use calculator, but let's do one if calculator wasn't available. This would be x to the positive 5/2 if we brought it down to the denominator. To do that, we could think of, remember, something where there's a 2 on the bottom means we're going to have a square root there, and then to the power of 5, because there would be a 5 in the numerator. So if we put 100 in there, we get square root of 100, which we know is 10, and then it would be 10 to the 5th power. So if you add 10 to the 5th power, that's going to be 10 times 10 times 10, 5 times in a row, which means that we would have a total there of 10 times 10 times 10 times 10 times 10. So multiplying this together, we're going to have 1, 2, 3, 4, 5 zeros on it. So it'd be, with timesing it by 8, should be, sorry, 4 zeros, because you start with the 10. So that would be 100,000, 10,000, 100,000. So we should have 800,000 there. All right, so now, oh, yep, so I do need one more. Okay, so now we got that one. So now what we're looking at is what is that written out now? So if we're going to write that out to the third one, remember our expansion here is going to be this value at 100 over n factorial x minus 100 to the n. That's our Taylor expansion. That's just something you got to know here as we start with 0 and go to infinity, but we're only going up to the third one. So our first one there would be the value we have, 10 over 0 factorial, x minus 100 to the 0, which 0 factorial and something 0 power is both 1, so our first number is just 10. Our next one is going to be 1 over 20 is what we got, over 1 factorial, x minus 100 to the first. 1 factorial is just 1, and so this is going to be x minus 100 all over 20. All right, let's get our second degree one here. So that would be negative 1 over 4,000 over 2 factorial, x minus 100 squared. So 2 factorial is 2, and then if we multiply by reciprocal, this is going to actually end up being negative here. Negative 1 over, that'd be 8,000 then. And I'm just gonna put our polynomial on the top here, so this would be x minus 100 squared. All right, our last one back to plus here, and this one we got 3 over 800,000 over 3 factorial, x minus x minus 100 to the third power. So simplifying that one, 3 factorial is 6. So we would end up with, if we multiply by the reciprocal here, that would end up being 6 times 800,000 over 3. 3 would go in here 3 times. So it looks like if we simplify all that, that our last one ends up being x minus 100 to the third power all over 3 times, or sorry, yeah, so 3's would cancel because we had this times that, so this would be a 2. So 2 times 800,000 would be, yeah. So that would be our third degree polynomial. All right, let's have you pause the video and try one out here. See if you can find the fourth degree Taylor polynomial about x equals negative 2 for the function 1 over x. So pause it and try it out. All right, let's see how you did here. Hopefully you had a chance to try it. So over here, since we want the fourth degree one, you want to make sure you get to 4 here. So the first original function is just 1 over x. If we plug in negative 2, we should get negative 1/2. For taking derivatives, it's easier to think of this one as x to the negative 1. So first derivative would be negative x to the negative 2. I used my calculator to help assist in finding these values, so you should have got negative 1/4. Next derivative should be 2x to the negative third. Plugging in negative 2 would also give you negative 1/4. And then keep going with your derivatives, and you should have gotten these coefficients. So now making them into a Taylor polynomial here, 1 over x should be equal to the infinite series here of f to the nth power at negative 2 again, because we're finding at negative 2 over n factorial, x minus negative 2 to the n. One thing to notice here, you're minusing a negative, so we should end up with x plus 2 in these ones when you're doing that. So put the first coefficient in over 0 factorial, which is 1, anything to the 0 power. So I just wrote only that one. For the first one now, this to the first power, and it'd be over 1 factorial, but that's just 1. The next one, we got our derivative at second derivative at negative 2 over 2 factorial to the second power. Next one to the third power, 3 factorial, and the third derivative at negative 2, and then finally the fourth one here, and our fourth derivative at negative 2. Simplifying that, you should have ended up with this then as your fourth degree Taylor polynomial. So that was just all I'm doing with these ones is simplifying out like these to get those coefficient numbers. So just using calculator to figure those out. All right, hopefully you did well on that one, and that's using Taylor series, not at 0, at different values. At 0, we call those a special type called Maclaurin.